as we wrap up everything we've learned about the unit circle and we push and head towards spring break, we've got one final lesson to do between now and spring break. So the trade-off is, I know we've got homework due tomorrow on Friday, but the trade-off is then no homework over spring break. So I just need you to push through hard with me, one final lesson, and then we all get to take that nice week off. So we're just going to look one more time at the unit circle. We've become so familiar with this, but our final thing is going to be to add a couple more positions to this unit circle that don't necessarily have nice coordinate points like the ones that we have already, but they're still useful. So what we're going to do is we're going to look at the position right here and also the position right here. So these are positions between 0 and pi sixths, and then the position between pi thirds and pi twelfths. And to think about those positions, I'm going to zoom in a little bit, and we're going to think about just kind of that first quadrant position. And we're going to think about this in terms of 12s. Okay? So what I mean by this is pi halves is the same as, in fraction, 2/4 pi, right? I mean, we all agree that 2 over 4 is the same as 1/2. Or another way to write that would be to have written that as 3/6. That would be just as, that's an equivalent fraction. Or if we want to go to eighths, that would be 4/8 or 5/10. But the one we really want to look at is, what is it in twelfths? So 6 over 12. That also kind of matches us up to pi fourths here, and we know that pi fourths is 3 over 12. So do these other positions have a something for 12? And the answer is, yeah, of course. Pi thirds is 4 over 12, and pi sixths is 2 over 12. So maybe you can kind of see where I'm going with this, is that we can add a couple more positions that are in 12s. And so this one right here would be 1/12 pi, and this one here would be 5/12 pi. And so we've got a couple more positions on the unit circle we can add if we start to divide things up even smaller. We started dividing things in half, and then we divide things in thirds, and now we're going to divide them again. So we've got a couple more positions we can think about that are 12s. All right, now how do we work with that? In degrees, these also have the equivalent of a degree. So this would be 15 degrees, and then we know we have 30, 45, 60. So then what would that make 5/12? Well, we're now increasing by 15 equally every single time. So 15 to 30, 30 to 45, 45 to 60. That's going to lead this to be 75 degrees. Let me write it in a different spot. This will be 75 degrees, and then that gets us back to 90 degrees straight up. So now we can do some smaller degrees that we weren't able to do before. Okay, so thinking about that, I want you to think about some combinations of things. For example, I think how could we make 15 or 75 using the numbers that we have? If what we know already is 30, 45, and 60, how could we come up with 15? Just using those numbers and using addition and subtraction. So 45 minus 30, that would give me 15. But so would 60 minus 45. That would also give me 15. How could I come up with 75? Well, there's really only one way to do it, and that would be 30 plus 45 degrees, and that would be 75 degrees. So I want you to be thinking about adding and subtracting numbers to get new positions on the unit circle. We could take lots of combinations. We could do, what about 45 plus 60? Well, that would give me 105, and that would be, now where would that be on the unit circle? Well, 105, now that's going to push me over to right here. That's going to be 15 degrees beyond. So if I'm counting by 12s, that will be the 7/12 position. And if we're counting in degrees, that would be 105 degrees. And then we add another, there's 120 degrees. And then 135. We're adding 15 every time. 150. Well, and that's going to give me this last new one right here, which is degrees would be 165, but what would that be in twelfths? Well, that's going to be 11 twelfths. Okay, so thinking of adding and subtracting and how that works. It works in fractions too. Okay, you don't have to just use degrees, it works in fraction mode. And so if you have your fractions, the ones that we learned, if you've got 1/4 and 1/3, and well, let's see, I'll start with, and we've got half, and then I'll put a sixth out in front of that. We can do combinations of adding and subtracting for that. In other words, we could do 1/4 pi minus 1/6 pi, and that's equal to 1/12. Now, how do I know that? Well, because I think of all the 12s. 1/4 is the same as 3/12. 1/6 is the same as 2/12. So 3/12 minus 2/12 is 1/12. What if I added? If I did 1/4 pi plus 1/6 pi, well, that's going to give me 5/12. Well, wait a minute, how did I know that? Well, again, because I change everything to 12. So 1/4 is 3/12 pi, 1/6 is 2/12 pi, and if I add them together, I get 5/12 pi. So when you're doing radians, you always want things in terms of 12s. Always change the denominator. If you're adding or subtracting some of the fractions, always get a common denominator of 12 and see what that adds up to be. All right, so what's the point of me showing you all of these new positions? Okay, well, I'm going to show you the second thing. That was kind of the first thing. I'm going to show you the second thing, and I'm going to tie them together. All right, so that was item number 1. Let me just kind of draw a line here. Now we're going to start with item number 2. All right, we have learned how to do sine on the unit circle. How do we do sine of a plus b on the unit circle? So I'm going to try and relate that to something you already know. A plus b, if I put a square on it, some people mistakenly think the answer to that is simply a squared plus b squared. Now, we know that that is not right. Okay, a squared plus b squared is not the answer to a plus b with parentheses squared. We know that the correct answer is to FOIL, and a plus b FOILs with a plus b, and it produces first, outside, inside, last. A squared plus ab plus ab plus b squared. That is the result of FOIL. So we teach you FOIL. It's a little memory trick to help you remember the proper way to be able to work out a squared term. So I'm going to teach you something for sine of a plus b to help you know how to properly do that. All right, let's think about sine of a plus b. Let me show you what it's not. It is not just sine of a plus sine of b. That is the incorrect process. Some people think it's true, but it's not. Just like FOIL, there are 4 parts to sine of a plus b. And the 4 parts are sine, followed by a cosine, followed by a cosine, followed by a sine. There are 4 pieces, just like FOIL, there are 4 pieces to when you have to do sine of a plus b. The first sine uses the letter A. The first cosine uses the letter B. The next cosine uses the letter A, and the next sine uses the letter B. And what's between them is addition. Sine of A, cosine B gets worked out first, and then cosine A and sine of B. So it's one of everything. 1 sine A, 1 cos B, added to 1 cos B, 1 cos A, 1 sine B. This is the formula for how to work out sine. And you'll memorize that. I'm going to help you memorize that in just a minute. There's also a formula for how to work out cosine. And it's not just cosine A plus cosine B. That is not true. So we'll cross that out. Okay, well, what's the right way to do it? Well, again, there's 4 pieces that happen in a certain order. Just like FOIL happens in a certain order, there's 4 pieces. Cosine starts with cosine. Okay, the sine one starts with sine. The cosine one starts with cosine. The difference is that the cosine is 2 cosines in a row. It's cosine A and then cosine B right in a row. So it has a different beginning, but it has the same term as the second term. And then we have the sine of A and the sine of B. Now the biggest difference, besides the order, is that cosine is a subtraction. So it's cosine A followed by cosine B, and then sine of A followed by sine of B with a subtraction in the middle. That's that formula. So here's how we memorize this formula. You've got FOIL, you've got SOHCAHTOA, you have all these little things that we teach you to help you memorize formulas. The one for here is just like a little memory chant. And it goes like this. And I wish I could like highlight the words while I say it, but I'll just underline them. It goes sine, cosine, cosine, sine. It just has a rhythm to it. And if you say sine, cosine, cosine, sine, I'll try that again. Sine, cosine, cosine, sine. Followed by cosine, cosine, sine, sine, sine. The last time I say sine, let me say that again, cosine, cosine, sine, sine, sine. I said sine 3 times. The last time I say it, I'm saying S-I-G-N as the word, which means there is a sign change in the center. So when I chant it all out together, it goes sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Just has a little rhythm to it. It feels silly, but if you even like beat out the rhythm on your desk, it helps you to remember how it's going to go. So I'm just going to kind of tap it out. So it's sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And that last little quick beat where it's sine, sine, sine helps you always to remember that you're going to change the sign in the center. This same rhythm works for sine of A minus B and cosine of A minus B. They work together. And so the pattern would go sine, cosine, cosine, sine. And I just realized that I made a mistake, so let me go back and fix that before you copy it down. We've got a B here in the center. So we've got sine, cosine, cosine, sine, followed by cosine, cosine, sine, sine, and then a plus in the middle because we're changing the sign. The other one stays subtraction. Subtraction stays subtraction for sine, but it switches sign when you're doing cosine. So we've got sine, let's see, try it again. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. All right, so how do we put all of these things together? So we have 2 topics now. We just talked about the 12ths on the unit circle and this formula to help you add and subtract numbers. All right, so you're going to put them together and you're going to do questions like this. What is the cosine of 75 degrees without your calculator? Well, the cosine of 75 degrees is going to be coming from 30 plus 45. Okay, 30 plus 45 is 75, so you're going to switch it into an addition. Then you're going to use the formula. And the formula for cosine is cosine, cosine, sine, sine, sine for subtraction. Then you go and fill in the numbers. 30 degrees, 45 degrees. 30 degrees, 45 degrees. And then those 4 numbers, just like FOIL had 4, these have 4. These are all on your unit circle. Cos 30 On the unit circle, I picture your unit circle. Cosine of 30 degrees is square root 3 over 2. Cosine of 45 degrees, picture your unit circle, that's square root 2 over 2. Sine of 30 degrees, picture your unit circle, that's half. And sine of 45 degrees, picture your unit circle, that's root 2 over 2. So we have cosine, cosine, sine, 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 subtraction in the middle. So put it all together. Square root 3 over 2, and square root 2 over 2 makes square root 6 over 4, minus square root 2 over 4. Let's have a common denominator. So square root 6 minus square root 2 over 4. Now you cannot combine the square roots. Don't tell me that the square root of 6 minus the square root of 2 is the square root of 4. That is illegal. You can't subtract square roots. You can combine common denominators, but you can't subtract square roots. And that is the final answer right here. That is the answer to the cosine of 75 degrees. Does it work in radians? For sure. All right, let's try a radian one. Okay, if we want to do a radian one, so let's say we want to do the sine of 7/12 pi. Okay, well, 7/12 can be broken up into 3/12 and 4/12. Okay, 3 and 4 is 12, or 3 and 4 is 7, so in 12s. Those can be simplified. 3/12 is the same as 1/4. 4/12 is the same as 1/3. So you change the 12s into their fraction. And then you use the formula for the cheer or the chant for sine that is going to go sine, cosine, cosine, sine. Because it starts with sine. Sine always starts with sine. Fill them in. 1/4 pi first, 1/3 pi second. 1/4 pi first, 1/3 pi second. And in between them is a plus. And then we go to our unit circle to get these 4 numbers. Sine of 1/4 pi, we know is square root 2 over 2. Cosine of 1/3 pi, we know is 1/2. Plus cosine of 1/4 pi is square root 2 over 2 again. And sine of 1/3 pi is square root 3 over 2. So this time we have square root 2 over the denominator 4 plus the square root of 6 over the denominator 4. And they have common denominators, so I can put them together, but you can't add radicals. You can do common denominators, but you can't do radicals. All right, one more example. So what do you have if you have to do the tangent of something? Pi fourths plus, say, 2/3. Well, what do you do for that? Okay, well, we know that tangent is sine over cosine of pi fourths plus 2/3. So then you're going to have to do the 4 for sine on the top and the 4 for cosine on the bottom. So it's going to go sine, cosine, cosine, sine. And then the bottom would be cosine, cosine, sine, sine. Change it to a minus. Top stays a plus. Okay, only the bottom changes. And then you fill in. Pi fourths comes first, 2/3. Pi fourths comes first, 2/3. Pi fourths, 2/3. Pi fourths, 2/3. And so now you have 8 of them to figure out. So we'll just do them in order. Okay, take it one at a time. Sine pi fourths, that's square root 2 over 2. Cos 2/3, that's negative 1/2. Plus cos pi fourths, square root 2 over 2. Sine 2/3, square root 3 over 2. Okay, there's the first 4. And the second 4 on the bottom, square root 2 over 2 and negative 1/2 minus square root 2 over 2 and square root 3 over 2. So when we clean this up, we're going to have negative square root 2 over 4 plus square root 6 over 4 and negative square root 2 over 4 minus square root 6 over 4. So there's common denominators all over the place. And the common denominators will reduce because you have a common denominator on the top and a common denominator on the bottom. So we are left with the negative square root 2 plus the square root of 6 over the negative square root of 2 minus the square root of 6. Now nothing else reduces. Okay, you can reduce common denominators, but you can't reduce addition or subtraction. So that is the final answer. The only last thing I wanted to have you think about would be, what if you had to do this problem slightly backwards? So like, what if you had to do the cosine of 20 degrees next to the cosine of 80 degrees, okay, minus the sine of 20 degrees and the sine of 80 degrees. All right, well, those 4, 1, 2, 3, 4, and the sign in the middle matches to the formula for cosine. So this is the cosine formula. It's the cosine formula for an addition problem. Because remember, in the cosine formula, the sign switches. And the 20 would come first, and the 80 would come second. And then if you put those back together, it's the cosine of 100 in degrees. So you can work the formula backwards, too, and shrink it back down to its original form from its larger form. All right, good luck with this. I'll see you guys tomorrow.